Good morning, everybody. What is today's date? Today is just 17th, Sunday, right? Sunday means obviously there is presentation. So already the presentation is displayed in the smart board of Anupam Vidyasadan, right? Today who is going to present at first? Anuja Thapa. And later on our friend Pranil Maharjan, right? If so, at first let's welcome on the stage Miss Anuja Thapa to present on the topic force and motion. Give her a big round of applause.
Namaskar and very warm good morning to respected sir and my dear friends. As you all know, it's me Anuja Thapa from grade 9 standing in front of you to present about the topic force and motion. So I would like to start. Here are some contents. They are force and its types, rate of displacement and distance, speed and velocity, uniform and non-uniform motion, acceleration and retardation, numerical, graphical representation of linear motion, types of time graph, equation of motion, relation between u, v, a and t or first equation, relation between s, u, v and t or second equation, relation between s, u, a, t or third equation, and also relation between u, v, a, s or fourth equation. And things to remember: numerical, inertia and its types, Newton's different law of motion, elasticity and plasticity. So force and its types. Force is the factor that brings changes to the position, size of a body. There are force has two types. They are balanced force and unbalanced force. Balanced force: when the number of forces acting on a body do not change its states of rest or uniform motion in a straight line, the forces are said to be balanced force. For example, tug of war. Second, unbalanced force: when a number of forces acting on a body changes its states of rest or uniform motion in a straight line, then the forces are said to be unbalanced force. And here is the figure of balance and unbalanced force. And here is the definition of rate of displacement. Rate of displacement: average velocity av is the displacement s per unit time t. So it is known as rate of displacement. It is considered as a vector quantity. Its formula is s by t. And rate of distance: average velocity av is the distance traveled d per unit time t. It is known as rate of distance. It is a scalar quantity because it doesn't occur in particular direction. Its formula is d by t. So here is speed. Speed is defined as the total distance traveled by an object per unit time. It indicates how fast or slow an object is moving without taking its direction. It is scalar quantity. Velocity. Velocity is defined as the rate of change of object's position with respect to time in a specific direction. It is a vector quantity. And here is And here is the figure of speed and velocity. There are two types of motion. There are uniform motion and non-uniform motion. Uniform motion, a body is said to move with uniform velocity if it covers an equal distance in equal interval of time along a straight line. The velocity is the same throughout the uniform motion. Uniform motion is called constant. It is also called uniform motion is also called constant velocity. And non-uniform motion. A motion is said to move with non-uniform velocity if it covers an equal distance in the equal interval of time along a straight line. This velocity is also called non-uniform velocity or variable velocity. Acceleration is defined as the rate at which it changes its velocity over time. Acceleration is vector quantity, meaning it possesses both a numerical magnitude and direction. Its formula is v minus u by t. And retardation. Negative acceleration is also known as retardation or deceleration. If it is said that the acceleration of a body is minus 5 mls square, it means that the retardation is 5 mls square. And here is the numerical of acceleration. If the car traveling at a velocity of 4 mls along a straight line speeds up uniformly to the velocity of 6 mls in 2 seconds, find the acceleration. Solution here: initial velocity u equals to 4 mls, final velocity v equals to 6 mls, time taken t equals to 2 seconds, acceleration equals to what we know that a equals to v minus u by t, or replacing the value a equals to 6 minus 4 by 2, and here is the answer 1 mls square. Therefore the acceleration of the car is 1 mls square. Now I will consider my friend on you to
Okay everyone, we're going to this only also. We're going to respected by Studio Thought. As always, Pranil Maharjan is standing in front of you to present here some chapters of force and motion. Now I like to start my presentation. Graphical presentation of linear motion. No. A graphic is a meant to present basic information on about different events to describe the motion of an object. We use line graphs. The line graphs of the motion show the this will the velocity is present on the time. It has two types of time graphs. There displacement time graph and the velocity time graph. Did you like it? It is very easy. Look here. Displacement time graph. Displacement time graph represent the interrelation between the change in position in a straight line, displacement and the time taken to bringing about the change in the position of a body. It indicates that the motion is uniform or that it has uniform speed. Velocity time graph. A velocity time graph shows the speed and the direction in the which an object travels over specific period of time. It is also called a speed time graph. The velocity of the object is expressed on the vertical axis and time on the horizontal axis of a velocity time graph. Equation of motion. Equation involving displacement, initial velocity u, acceleration and the time of the motion of moving body are known as the equation of the motion. These equations are derived from the definition of the average velocity and the acceleration considered a body moving with a straight line with uniform acceleration as shown as in figure. Different equation of the motion. So, relation between u, v, a and the it or first equation. Let as shown, a body as an initial velocity u and it's subject to a uniform acceleration a, so that the final velocity is the v after the time interval. Now by the definition of acceleration we have a is equals to v minus u by t, or at is equals to v minus u and v is equals to u plus at. Relation between s, u, v and t or to second equation. Let's assume a body is moving with the initial velocity u. After time its final velocity becomes v and the distance traveled by the body is s f or uniformly accelerate motion. Average velocity is the mean of initial and final velocity. Therefore we have av is equals to u plus v by 2 first equation, av is equals to s by t second equation. From equation is equals to u plus v by t is equals to s by t, or 2s is equals to v plus u plus v bracket close t, s is equals to u plus v. Relation between s, u, a and t or third equation. Let's assume a body is moving with an initial velocity u. Let its final velocity v after a time initial t and the distance traveled by the body b s. Then we already have v equals to u plus at. First equation s is equals to u plus v into t by 2, putting value s is equals to u plus bracket open u plus at bracket close into t by 2, or s is equals to 2u plus at t by 2, or s is equals to 2ut plus at by 2, s is equals to t plus 1 by 2 at 80. Let's assume a body is moving with an initial velocity u. Let's find its final velocity v after a time taken, and the distance traveled by the body b as we already have. V is equals to u plus at. For the equation, s is equals to u plus b multiply t by 2, putting the value s is equals to u plus b by 2 into b minus u by a, or s is equals to b into b minus u, or 2as is equals to b minus u. B is equals to u plus 2as. Things to remember: when a body is thrown vertically upwards, the final velocity at the maximum height v equals to 0. Here a is equals to minus g. When a body is falls vertically downwards, the initial velocity u is equals to 0. Here a is equals to plus g. The value of the retardation is always negative, minus a. In the problem, if three quantities are given, we can calculate the rest quantities using the equation of the motion. Numerical: a bus starts from the rest if the acceleration of the bus is 0.5. What will be its velocity at the end of 2 minutes, and what distance will it cover during that time? Solution: here initial velocity u is equals to 0 meter per second. Acceleration a is equals to 0.5 meter per second. Time taken 2 minutes is equals to 2 into 60 is equals to 120. Final velocity is what? Distance covered s is equals to what? Now we have b is equals to u plus 80, or b is equals to 0 plus 0.5 into 120 is equals to 60 meter per second. S is equals to u plus b into t by 2, or is equals to 0 plus 60 into 120 by 2 is equals to 3600 meters. Therefore, the final velocity of bus is 60 meter per second, and it will cover 3600 meter in 2 minutes. Kira. Inertia: the property of a body due to the which remains or tends to remain in its original state of rest or uniform motion in straight line unless an external force acts on it is called inertia. Its types are inertia rest of rest. Inertia is the property of a body virtue of which remains or tends to remain in a state of rest unless external force acts on it. Example: inertia of motion. Inertia of motion is the property of the body remains here tends to remain in a state of uniform motion along a straight line on less surface acts on each example. Passenger in the moving bus jerk forward when the bus stops suddenly. Inertia of direction. Inertia of direction is the property of a body virtue of the which it maintains or tends to maintain its the direction of motion on less external force acts on it. For example, when the wheel rotates high speeds, the mod string to the wheel files of the
Wheel, that wheel,
Wheel.
wheel flies or can not wheel.
thing.
Wheel.
Newton's first law of motion. Newton's first law of motion states that every body contains its states of rest or uniform motion along a straight line unless an external force is applied to it. Newton's second law of motion. Newton's second law of motion states that the acceleration produced in a body is directly proportional to the force applied to it in the direction of motion, and the inversely proportional to its mass. Newton's law of motion. Newton's third law of motion states that every action there is an equal and opposite reaction. Action and reaction always acts on different bodies. According to this law, whenever one body exerts force on another body, the second body also exerts a force of equal magnitude on the first body, but in opposite direction. Elasticity. Elasticity is the property of the solid materials by virtue of which they tend to regain their shape after the removal of an external force. Bodies with greater elasticity requires more for standing in their shape quickly after the removal of the force. Plasticity.
Not more far.
Force.
More force.
Yes. Plasticity. Plasticity is an important condition for machine tools, structure, brides on the civil, farmers, equipment, bodies, and many household structure and farm that must retain their shape. Plasticity is the property of the solid materials by virtue of which they tend to retain their deformed shape even after the removal of the external load. Thank you.
Okay, so children, what you have to do, you need to practice more. Understood or not? This is the time to learn. Number one, you need to read the whole chapter. Second one, make the slide. Third one, what is written in the slide you must know. Only reading thoroughly, that is not the presentation. You have to look at the presentation slide and explain to your friends. Remember. Third chapter was mushroom and fourth chapter is, what is that? Force and motion. So we have completed force and motion. I think some numerical problems, I don't know, the whole questions are over. So in next period we will begin new chapter. What is the new chapter? Machines. We are doing machines also, right? Okay. Next Sunday there is presentation of the chapter machine. Who is going to present? Roll number? I think that is chapter 8, right? Chapter 8 means roll number 8. Who is roll number 8?
At that time I was 9.
Now it became 8. I think somebody left, right? Your chapter is 8. What did you prepare and send?
Chapter 9.
Namika has sent? Pavitra has sent. Okay, Pavitra then. Pavitra and Pranil, who is after you? Rijan Srestha. Okay, Rijan Srestha. But Rijan Srestha, he becomes busy. Sometimes he goes here and there. Who is after Rijan Srestha? Deepsan. Why do you say Pranil? Why do you call Pranil? So, Pavitra and Deepsan's turn is to present the chapter machines, to prepare slide and submit. Okay children, everybody take out the book and read this chapter once again.